Okay, we'll be getting started right now. Thank you very much, everyone, for taking our time to join into this session. And I'm just, as you might have seen, the focus, yeah, just as you've seen, um, the focus is on leveraging structured outputs and then function calling for reliable generative AI workflows. And then you might be wondering that why I should be having this. I mean, why this topic? Maybe it sounds very long and technical, but the whole focus is basically for those that build, right? If you're building AI workflows and you're getting started in generative AI, or maybe you're even a prompt engineer, whatever it is, right? It exposes you to so many things, right? That you can do with structured output. I believe someone here, maybe while trying to build a solution, might have tried, oh, make sure you return everything in JSON, or make sure you return everything in a structured format. You give it a schema, name, this, blah, 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 extract of this, but still, I mean, still generating AI, right? Models will still tell you, okay, this is what my response is like that. This is what my response at the top. You don't even need it at all, right? And maybe you're trying to use some parser that will just pick up the JSON part. And sometimes it still fails, but with structured outputs, you're able to do a whole lot, abstracting that whole process. So we'll get started with the basics, right? Before we move into a quick demo later on. If you know a couple of people that you think could be interested in learning about this, do share while we'll get started. Thank you very much. So a second to switch my screen to a different one, my slides basically, and then we'll get started. Okay, please, can you confirm that you can see my screen, please? Anyone? I mentioned our focus today is on leveraging structured output and function calling for reliable generative AI workflows. Right. And then just a brief introduction about myself. My name is Samuel Bangwela. I'm a Go student, Microsoft student ambassador, right? And then I'm an ML AI engineer. Yeah, that's pretty much about me. I'm also a student at the University of Lagos, electrical and electronics engineering 500 level, my final year. And then I'm happy to be here with everyone. So, yeah, moving on, right, into the main flow. Like I mentioned, there will be a brief introduction for those of us that are just getting started with generative AI or building for the first time or anything at all, right? So, what is generative AI? From what I've drafted out here, right, basically just simplifies everything. It refers to models, right, or solutions that create new content, such as text, code, and images, right, by learning patterns from large data sets. So I think many of us will be familiar with what data sets are, right? It's basically a collection of information. It could be text, images, just how we outlined here already. It could be tabular data that we use mostly for predictive machine learning and so many other things like that. You get me? So a data set can come in any form. But then for large language models, right, how they work, like the 4O, right, which is a multimodal large language model because it can also interpret images, right? They work by predicting the next token in a sequence based on the context that they receive. And by context, what it means is you're talking, maybe, for example, I use the name of someone on this call now, maybe Olakunle, and I say, Olakunle is playing, right? If I'm going to predict the next word, let's say I kind of know that, okay, it's a male name, right? Well, let me even use Daniel, for example, which is English, right? So you can infer it, right? It's maybe it's typical for a boy to be playing with a ball, right? Football. So if an LLM is predicting a sequence of words and it's like predicting, okay, you give it Daniel, Daniel is playing, and you will probably have there are different probabilities of words that predict next. Maybe like ball, or maybe you can actually predict a full stop. So a token, a full stop is also a token because it's like end of sentence, right? So maybe it releases full stop, or it predicts ball, or it predicts playing a game, or I mean, okay, of that is now two words or something, right? But the one with the highest probability is the one that is eventually used to that sentence. So when you ask a question, right? And basically, that's how it works. Just like you have multiple words being predicted over and over to complete series of sentences, and then you get something that looks like, a full essay, or maybe a short response. However, it's response, you get me. So there is a whole lot that goes into it. And for some of us that are technical, we understand that most large language models or multimodal language models are powered by the foundational architecture of the transformers, right? You might have read The Attention is All You Need, paper, and all of that. It's basically an architecture of machine learning that helps in all those predicting. You have the encoders, you have the decoders, and all of that. But we're not going to be going into all of that. But just to understand how generative AI works, right? And the foundation. So the outputs are inherently structured, which is what we're going to try and focus today, because it's text, or it's image, or it's anything, right? There's no structure. There is no exact way of, oh, okay, this is going to work. Anything with structure is probably be tabular, or there's just a response, or there's a kind of structure that you get. I don't know if you follow me. And large language models do not do that for you unless you customize them to be able to. So they are free from the output is usually like free from text, right? Rather than machine readable data. And the engineering challenge is making responses reliable enough for production, right? You're building a generative AI solution. Not everything is going to be chat, 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 chat. They're not always going to be the chat solution. You might use LLM solutions for something structured, which of course today will be something on quiz generation. Maybe you're building an edutech solution, right? There are different ways it's going to come in. And like I said, not everything is going to be chat-like. So if it's going to be chat-like, then of course the unstructured format is already like pretty for you. Maybe just a little bit of cleaning. So moving on now, like we already started, the problem of unstructured large language model outputs. Prompt hacking is one. So like when you are forcing JSON, respond only in JSON, it breaks unpredictably across outputs and model version, meaning it's not reliable and it's not scalable. Let's say, for example, you are using GPT 3.5 turbo, for example, which is like phased out kind of now. Or let's even use GPT-4 mini or GPT 5.1 or something, right? They are not going to respond the same way because they are different models. So if GPT-4 mini is responding well to your respond only in JSON and is working well, by the time you want to use a better model, right? Maybe you want to switch along the line or have a particular feature that will use GPT 5.1 or something. If you use that same prompt, it might not work because the different model and the way they will respond is going to be different, right? So you have to keep changing your prompts every time you have to switch to a different model, or maybe the model is phased out and you want to upgrade. You have to keep switching. And second thing is no validation, right? Without the schema validation, you get fields, wrong types, and unexpected keys that crash downstream systems. So basically, what this means is that, let's say today you in your prompt you said, okay, extract name, extract class, extract all of these, extract. Okay, let's say it's even a to-do voice note, for example. You have the transcript of what somebody wants to do, right? And you want to extract the timeline, the priority, whether it's medium or high priority, all of that. Sometimes it might just have some of them missing because that rule, there's nothing enforcing it that each time you are giving me a response, the priority must be there. There's no gathering. No matter how you put in your prompts, there's a free flow. But if there's a schema that forces it, either you return null or you return a value. But of course, LLMs can still hallucinate, because if it's not in what the person said, they probably just hallucinate something, right? But let's say you always want that field to be filled. Prompt hacking will not probably solve that, or will not be reliable. And it's also not production ready. So production systems need guaranteed, validated, and machine readable responses, right? Not best efforts, text percent. We've kind of explained this already. So that's the whole idea around, or the problem basically around unstructured LLM outputs, and how or why we need to solve them using a different approach than just prompt hacking, or the default way we use them, right? Just to be sure if anyone can still hear me, can I get any confirmation? Maybe a thumbs up or something. If you have any questions, thank you. If you have any questions, you can drop them in the chats. Definitely. I'll be checking through from time to time. I believe everyone can access the chat. So our next phase is structured outputs, right? We've talked about unstructured outputs. How do we make them structured? So our focus is on OpenAI, right? There are other solution providers or generative AI providers also have their way of implementing function calling and structured outputs. But we're just going to focus on OpenAI and how we can do that using the Azure OpenAI service from the Azure portal. So now OpenAI structured output lets you constrain model responses, and any other service provider or generative AI or AI company basically that builds LLMs, right? Most, or if not all, currently have structured outputs configuration that let you constrain your model responses to match a JSON schema you define upfront, right? You have to define the schema before. Not like you can make it agentic that to define the schema first and all of that. But I mean, for the solution that you want to build, you don't want it to be predictive, right? You want to have a structure. So you pass your schema using the response format parameter, this types of code now in the API call or the SDK that you're using. And then the model is guaranteed to return valid JSON that conforms to it. The API automatically validates types like strings, numbers, so you can specify what data type you want to have in any field, right? You can have a JSON, you know how JSONs work. You can have multiple fields, right? And you can specify the data type that should be in a field. It could be a string, it could be numbers, and enums, meaning like, let's say it's categorical, for example. Let's say you have class. You want to extract the person in a particular class. So the person, you have GS1, GS2, for example, so GS3, right? So using secondary school phrasing now in Nigeria, right? You can define that in an enum. So meaning whatever the person might have said, or put it by the time it's extracting it, right? Let's say the person put like grade 7 or grade 8, is able to infer or whatever. I mean, it's an LLM, it can also reason, there are reasoning models as well to get that, okay, this grade 8 that this person is talking about is GS2, right? And it makes sure that it's GS2 that is there, not like it does output, oh, grade 2 or grade 8, or hallucinate something that does not even make any sense. You get me? So this helps create structure, and the nested object, so you can have a dictionary within a dictionary, or a JSON within a JSON. I don't know if you get what I mean. So like nested dictionaries in your output. Right? Let's say under name, you could have first name, last name to separate text, separate those. Then you still have your age and other things that maybe you want to decide to extract, right? And you never have to write post-processing or regex logic again. Regex is basically just regular expression where you're trying to use the structure of the text. I mean, age is probably maybe most times two figures, right? Maybe if you see two figures, extract it as age. You don't need to do all of that because the structured output API response will handle everything. So I'm just basically trying to give a thorough overview of this. So by the time we get into code, everyone will understand what we're doing. So function calling as well is similar to structured output. Not exactly, but what this does is that if you're also building a solution, let's say um, you're within a chat interface. This is mostly applied within chat interfaces. So let's even use maybe ChatGPT or whatever AI chat assistant that you use, right? Sometimes you say, okay, you want is to create a visual or a table. Like, no, I'm not talking about markdown tables now, but like actual tables that maybe that are visual, or if you use Claude, for example, or whichever one, to be honest, like it's open maybe a side where there's like an HTML that is generated and you can view some samples of an image or some graphics, right? It is function calling that handles that based on your prompts, it's able to like, okay, no, now this person is trying to access a particular function that I can do. There are tools that are integrated. Some have you can create PDFs, or you might have seen ChatGPT try to generate a code. Like I said, hey, that's another use case. Now you want to leverage this code any analysis. For example, you wanted to create charts, right? Yeah, you can do that within ChatGPT to create charts like images of analysis from a data or whatever it is, right? Sometimes you might see that it's writing some code and it tries to run it within the interface too. That's a function that is being run. But how did you know that, okay, I'm to call that function? It's based on the function calling system that you've implemented. Meaning, based on the person's question, is able to infer that, okay, to achieve or solve what this person is asking, I need to leverage some function that I can do. Because LLMs cannot do everything. LLMs can write code, but they cannot test the code. A simulator or whatever tool will have to test that code, right? So if it generates a code and the simulator tests it, just like a tool or a function, right, that is code and it works, it gives you the image and everything, and then you can, continue your solution or your chart or whatever that you're doing within ChatGPT or whatever AI chat assistant you're using. So that's just the whole flow of how everything works, right? And then basically you define the schema, you call the API, and you have your output already, so it's left for you to use. This is an overview of how it works. I generated this using Escali Draw. It's a really nice visual tool that you can use to like draw flowcharts or patterns and everything. So for structured output, just like we've explained, you can look at in the your system, right? You have title and schema and everything, how you want it to be output. That's on the right side, the green side. You see a machine ready response, no rejects, basically. If you move right from the API call, which is developer up to the OpenAI API, you can see that the JSON has been specified, the response format, basically with your prompts and everything, with the schema that is meant to respond with, and that is passed. So the constraints, whatever tokens and everything is being used, is still the same in this process. The grammar that guided decoding, schema validation, using Pydantic and everything. However, OpenAI, for in this use case, I've been able to implement the structured output to validate. That is run for you. You don't need to start doing any rejects or anything like that, right? And just like we mentioned, there are different use cases. For today, we'll focus on quiz generation. You can use it in auto grading. You can use it for learning management systems. You can use it for classification. Let's say, for example, you want to classify something that you don't have in a data set, right? Maybe you have an image or a video, you want to interpret what is in it, but you don't want it to just be text. You want it to have like, okay, you extract this, extract the title, extract the length, extract everything, and it gives you all the details, right? You can use structured output for such kind of classifications or extractions, and you can use it for state management as well. If somebody is saying some things that is out of scope, you're using maybe a LMS system and they're asking about biology, and they're in the biology interface, and they start asking about mathematics. It should be able to know that, oh, okay, this person no longer asking about mathematics, about biology. Tell them that they can only talk about biology here. I don't know if you get me. So you can use it to manage states or whatever flow you have in your system. Same thing as well with function calling. You have your application, you define the schema, you define the functions. Basically, you have to create the functions. Many of us might be familiar with MCPs. So tools like that, maybe you're connected into the internet. You want to enable your solution to be able to browse. Your AI solution to be able to browse. LLMs cannot browse the internet on their own, right? You're connecting to tools that can now browse. So it's named to call this function and browse the internet. You get that. So it's just like you're extending its capabilities. So maybe you want to create a function that can search the internet, like can Google search or whatever it is, or that can run some calculations. You can build those functions. Then in your whole flow, let the solution know that, okay, when this person is beginning to say this, blah, 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 redirect them to that function and use that to augment my response I will give to the user and all of that. So we've covered most of what we need to cover, right? For your schema design, you need to ensure some certain things. You need to have some principles. Whatever field that you know is required, set it as required. Most times it's easier to just set off fields as required, and then you can always define that, okay, this particular part should be null, Like that means it can either be empty or not. But just set off fields to be required to kind of maintain structure. You can use enums too. I gave an example of enums, whether you're trying to extract classes. And you can nest objects, right? I give example of, okay, name, and then you nest it to first name and last name instead of just the full name being extracted and all of that. So keep it flat. Don't overcomplicate your schema, right? To keep everything simple. So yeah, case study is maybe the material, structured output, validates the recipe, quiz, JSON, and then maybe use function calling to do some other things as well. But in this case, we're not going to be using a text material, right? It's just a prompt, and generative AI model solution is going to give an output. I'll also be leveraging a bit of agentic coding, so you can see how much you can even do generating AI code on the fly, even within VS Code. Maybe you can use Claude or Codex or whichever one, right? These are some sample code and all of that. I had some other ones to that I defined, so I just put them here. So let's get started, right? We'll start with the quiz generation and a bit of function calling, and then I'll show you a sample scenario of a solution built by MLSA Unilag community or Nigeria community at October last year. And it's an open source project basically. And then you can see how a structured output or function calling based solution, generative AI solution works in real life, or yeah, basically. So I'll be switching my screen now, and then we'll get started with code. But if you have any questions, please kindly unmute, and you can ask, and I'm very ready to answer certain questions that you might have currently. I hope I'm not speaking too fast. Anyone has any question? Okay, so I'm guessing. Oh, okay. I can see Judah's hand here. Please go ahead.
Okay. So for advice, like when you're using AI, sometimes I see challenges that like apart from just using AI to like code, because now a lot of challenges actually allow people to use AI to code. But you feel like they usually set a baseline that like your AI model needs the model they are creating with AI needs to beat this performance. So you need to improve like the base, like if we were to give it to GPT normally. GPT, there is a particular baseline that GPT cannot pass, like a particular accuracy. But you want to see who can use AI to pass that accuracy. So, like, if we're given a challenge like that, how would you tweak your prompt in order to achieve that high accuracy?
Okay. Can you come again with that question? I'm trying to get when you say accuracy and everything.
So, the context of that question was for a ML challenge. But, like, in general, if you wanted to your AI to like what's the name, give you a better response than what it normally give? Like, what are the steps you take?
Okay, great. Yeah, I understand your question now. Um, Evaluation basically, right? You need to be able to have a human in the loop kind of system that can evaluate. You can also build some structured text, right? People do agents versus agents, like a model evaluating a model and different things like that. You have to build an evaluation system. And one of the ways that I can help with that is also having structured output. When you know that your model is always going to follow a particular schema to give you a response, right? Then you can easily evaluate from there, unless it's just a chart evaluation that you want to do, right? If it's just a chart evaluation that you want to do, then that's totally fine as well. But you can set a baseline, right? A scoring metric. Okay. Um, if this response, right? You design a scoring metric based on, let's say it's an educational system. You want to vet it against maybe two or three responses, maybe generate two or three responses, right? That's one system you can use. Let it have like different scenarios of like multiple prompts, 4, 5 prompts, get their responses, have a system that will score them. From there, you can now see, okay, this is the prompt that works best. And from there, you can notice nuances that affect a particular prompt, right? Maybe you notice that, okay, this prompt is performing better than this prompt in this particular scenario, but in this one is now failing, right? So from there, you can now start comparing, making comparisons that, okay, my prompt works best good in this. This one works best in another thing. How can I fuse them together to get a better response? I don't know if you get me. So you could have different ways you want to like evaluate, but basically it's more about running experiments, have options, then you can now evaluate and fine tune. Most time maybe you're fine tuning your prompt, right? And fine tune like backdates or backtrack from there. I don't know if that kind of answers your question. Um,
Yes, thank you. That answers it.
all right, good. Thank you. Kunle, I can see your hand as well.
Can you confirm you can hear me?
Your audio is very low.
Can you hear me better now?
Yeah, yes, much better.
So my question is like, so like if you're using based on the flow, should I call it flow chart now that you showed us the OpenAI like structure. So
Yeah.
if what happens when like the model has gotten to the maximum like token limit before the JSON object is closed?
Okay. Um, it's also part of what you do in your test, right? You have to make sure that whatever you are passing into your model, it can take it. But most models now can take up to maybe 10K plus tokens, 128K tokens, and a whole lot. So you might not have to worry too much, right? But of course, many times when it comes to like cost and pricing and everything, maybe that's when you now need to like start making sure that you're tracking inputs and outputs prompts tokens to know how much you're spending. But more often than not, I mean, in these days, right, most models are taking up to 128K, 64K, and even higher, So you probably don't have issue. But yes, it's a valid thing to consider. And then you can also use the max token limit as well, right? That response to be truncated, right, at some point where that token is going, that token max is going to be reached. Doing all you to Can you hear me, Conley?
Yeah, I lost you at the end. My internet is kind of bad.
Oh, okay. So yeah, basically, I was just saying that most models now can take up to 64K, 128K, and the rest. But like,
Okay.
you can also use the max token limit as well to make sure that your responses are truncated at some points when that limit is reached to help you even
Okay.
manage how much is generated each time. But more often than not, for your structured schema that you're going to define, it will take it because most models can handle a whole number of tokens right now for inputs and also for outputs. More
Okay.
importantly for inputs in this case, yeah.
All right. Thank you.
Yeah, thank you, Kundi. Yeah, Oluwashi, yeah, I can see your hand. You can go ahead. Yes, you can you hear me.
Yeah, good evening, Samuel. Good
Yeah,
evening.
good evening.
Thanks for the informative session. I just had a couple of questions regarding the part where you mentioned that the API would automatically validate your types, strings, nested objects, and also that data types. So you don't have to write like post-processing or regex stuff again. And it means that you've like shifted the responsibility of validating and ensuring that you have correct ensuring correctness. All of that has been shifted to the model. But in cases of like let's say, critical or sensitive applications, would this not kind of, it's not like against that idea or philosophy of having absolute correctness? I don't know if you get what I'm trying to say. Like, at the end of the day, don't applications that require that kind of that level of sensitive, or let's say like security applications, for example. Like there was one time that the CEO of Anthropic was um, giving an interview where he said that they can't, that the level of reliability they have for their models, and they can't really guarantee it for military applications. That was when like the US was kind of insisting that they apply their AI models in military applications. So, like at the end of the day, are safeguards not still necessary? Like, would you just give AI models 100% accountability for the schema? I don't know if
Well, yeah, I get what you're saying, and I mean it's still very valid as well, right? So just like when you solve one problem, another problem arises from it. Maybe not exactly another problem, but there are some loopholes, right, that will come from that problem. No problem, no solution is absolute, right? So this is just one way of achieving a better structured approach for your generative AI solution. And of course, I agree that, I mean, generative AI solutions, LLMs are still AI solutions, meaning they are probabilistic, right? They will definitely still make mistakes, and it's still even possible maybe for it to break out. But more often than not, this kind of system ensures like a guardrail, especially if you are working in a developer setting where you need outputs like structured output like JSON responses and all of that, and you want to ensure that it always remains that way, right? This is one way to ensure that. But like I said, of course, it's still generative. That's why it's generative. It's probabilistic. It's not definite. It's not absolute. So it's still prone to errors. So yeah, I hope that kind of answers your question.
yeah, thanks for your answer.
All right, thank you. So on my screen now, you're able to see the quiz generation schema, right? Um, I define some of my prompts here in a YAML file. There's system prompt, and then just a few things that was generated here. But under the structured output script, you can see how I define my schema. There's a type, right? This is just JSON schema, the name, essay block. So basically, essay is like, just want this question and the person can generate an answer, right? Um, basically a description, right? So you have a description of the question, what is this, blah, 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 how you want it to be defined in the response. You get me? I mean, in the generation, right? And then you also have the this. Okay, sorry, apologies. I already moved to here, but like the description basically is just like a prompt to guide the model on. Okay, this is what you are going to do, right? Say a block of essay style questions. Each item is an open response question where the model provides the authoritative answer and explanations, blah blah blah. But then when we move to the properties of this, right? We have a required item here, which is the question, and you can see from this is a nested um, response, right? So under questions, which is the first one here, you have a description of what it is, the items, you have the ID, you have the question and the explanation. You get me? So in the ID, it can just be anything, maybe 1 to 3. It's not really important, but I mean, it's something that you can always remove. But then the question is what is generated. So for example, let's say this is biology. What's the difference between mitosis and meiosis? That's the question, right? And then the explanation, basically explanation of the answer. Yes, of course, we are building a quiz generation solution. You are definitely going to provide answers to the people or to the users. So the explanation, what is you want it to give out. All right, generate. So basically, it's generating both the question and the answer in this case, right? So that's how you define it under properties. You get, and then this is just an example that the LLM can use to understand. Okay, this is how each output to be. So you can have like 2, 3, 4, 5 of this generated, and then you just extract that and pass to maybe the front end or something that will populate. Then we also have another one for multiple choice questions as well. We have the properties, and under questions we have multiple items, right? We have the question, we have the options, and in the options it's just four maximum options. So you can determine, you can input the minimum items and the max items of how many options you want to be. Because also you have to define the type. So you can see here when I talked about the type, there's array here, there is a type which is string. There is also the description, right, of what the options is. So exactly for answers, blah blah blah, to kind of explain to the model to know, okay, this is what I want you to do with this, right? And they will also have the answer in index. So these options are going to be four. And not in programming language, generally you start with zero index, right? So that's why I've defined the minimum as zero and the maximum as 3 years, since I'm always going to use four options. So from the front end part of things, when they see, okay, answer index of 2, they know that that is option C, meaning 0, 1, 2, that's ABC, right? Then also the answer explanation of what it is. And this is like an example again. So this is just a simple way of defining your schema and all of that. And then let's see how we can test this. For function calling also, I just designed some simple functions that can be called, like if somebody asks a question on getting dates. I mean, I believe we all know that LLMs do not have access to the internet and they are very bad with dates, right? So you need some sort of things to give it context of what the time is. So this is just a function, like for example, you can liken it to the programming function of ChatGPT when you ask it to analyze the data set and it starts writing some code that you can send, it's trying to run it and all of that. Let's imagine this get current date time is something like that, but this one is just to get time. When the person asks for time, it will know that, okay, that person is asking for time, to call this function and return updates the user. Calculate also, let's say somebody asks a question and all of that. There's just some regular expression stuff that is used to extract the questions. So I mean, what the person is trying to say, and then run this the output and give a response. So these are some simple things. So let's see how we can test and then get the output. I believe we should get the flow right now. I'll share my entire screen now. Yeah. Okay. So you should see my, let me open um my this home view, right? So we're here. It's I mean, I believe many of us use Fast API, so it generates the Swagger UI for you directly, and then you can just easily test. So if we test with let's test with structured output, I mean, which is quiz generation for MCQ questions, and we try it out. So I'm defining the difficulty, right? And I said, okay, I want 5 questions. So let me say I want 10 instead. And what topic should we define? Let's say Python programming might be easy, or let me say history of um, generative AI, transformer architecture. So this is a topic, and let's see how well it's able to execute. If we go back, we'll see, okay, there's some internal server error. Why did we get that? Okay, there's some missing parameter that I didn't include. Okay, let me see. Then I use some because of time to see how we can quickly troubleshoot this. So this is the endpoints just run. So you'll just wait a couple of seconds for it to run and try to fix that problem. So probably that there's some sort of mistake in the schema that I've defined. Also, unless maybe there are some updates that have been made. But let's see how well this is fixed and if we can run it again. So But basically, this is just a simple use case, to be honest. You can integrate into an application or whatever it is that you're going to integrate into, right? I just define the Azure OpenAI client here. This is how you can work with Azure OpenAI, right? You have your OpenAI key, your base URL, and if you are new to Azure, right, let me just run a sample of how we can get started with Azure. This is your Azure portal. You can create a resource here, right? You also have the Azure for Students that you can leverage. Let me get that and share in the chat so you can get access to that. But yeah, so as I was saying, you can now search for the Azure AI Foundry or Azure OpenAI. But most commonly now, the Azure AI Foundry is what is used for generative AI solutions in Azure currently. So you can either go via that route or you just search for Azure OpenAI, and then you're able to get access to the Azure OpenAI service. Let's see. Yeah, so the Azure OpenAI service, and you can create a resource from there, get your API keys and all of that. So let me quickly share in the chat. Um, for those that are students, I believe most of us here might be students, and you can get access to the Azure for Students here with that use case. So let's test again. I believe this has been fixed, right? All right, so let's go back to our use case and test. So you probably see that we won't be getting a text response. Let's see if it's running fine here in the server. Just wait a few seconds for the output to be generated, and then yeah, you can see what it looks like. All right, so we have our responses generated. So you can see how this works, right? You have a topic. So this does basically how the output is structured, right? So if you go to main, you see under the endpoint, let's just quickly scroll down to chats, not chat now, MCQ. You see that in the response, right, the inputs were passed and everything, but what was generated by the model is what we have here, questions, and it does itemize them, right? But these ones are just basically from what you inputted by yourself, and then the number of questions that was eventually generated and all of that, right? So if we see this, this is what is here. Then each question, what year was the transformer architecture introduced? Can anybody answer this? Okay, the answer is already there, but yes, 2017, right? See the explanation so you can display this to your user. So if there's anyone building an edit text solution here, this is a very interesting way you can build your solution without trying to hack prompts and everything, right? You can even just pick up this and use. Which company developed the original transformer model? That was Google, right? What is the key feature of transformer architecture? Which predecessor architecture does transformer in? Okay, there's a lot of questions about transformer architecture now, right? Okay, let's say this. What is the main focus of the research field known as generative AI? Content creation. I think that's obvious here. So this is one way it can work, right? And we can see the beautiful way structured app will give us a very simple case or format that developers, maybe front-end guys, can easily pick up, right? There's an ID, question 1 to 10. There's a question, there are the options and the answer index. So when the person answers, it knows it. And then an explanation, maybe the person gets it or fails it to show them the correct answer and all of that, or to help them understand that this is why you got this question wrong, right? So it's as simple as this, really, right? We've seen the structure. Let's see if we can test out with essay generation, right? Which is just basically another set of questions as well, but it's going to be open-ended. So let's use history. Why am I using a lot of history? I don't even know if I can suggest anything. Anybody wants to suggest a topic that we can generate questions on? I'll drop in the chat as well. I don't know. Let me say, um, so introduction to respiratory system, assuming that it's an editing solution now. So this is being generated, and then we should get a response very soon. Right. Okay, so we have the question. Describe the main structures of the respiratory system and their roles in the process of respiration, and see the extensive explanation he gave, right? So, of course, it's an essay question, meaning like German for maybe those that understand what I mean by German, or fill in the gap or something, whatever it is, you understand it by. This is how it is, right? And then you can now interpret and pass to the user whatever they want to do from there. You have an explanation that you can give to them as response. You have the question itself, right? I mean, of course, this one does not have options because it's open-ended. So I think we've done justice to structured outputs, and let's test out function calling. I mentioned something about accessing chat, right? And we have some examples that says that I should test with what time is it, right? If you ask any model what time is it, it's going to hallucinate definitely. If you have ChatGPT, it's going to tell you the time because it has access to maybe the internet or whatever function that is using to pull that information. But if you prompt a model directly, what time is it? It's going to hallucinate something. It could tell you 19, the date it was created or something. So it could just give you a random figure. You can try that out, right? But let's test this out. You see the flow of everything. So if you go through this function, right, under chat, see what happens. Uh, Chat with functions. This is the endpoint here. I mean, the prompt, the function is handling that. We go into that function. We can see it's under function calling here, and we go to chat with functions, right? So what is happening here? The prompts and everything are loaded in, right? And then it knows, okay, these are the tools I have access to. Where are those tools? It's getting it from the get to schema. So just follow me, trying to explain the whole flow. From the get to schema, you can see how it's trying to call different functions. It has them in some prompt somewhere where it has saved their names. So under prompts functions, you can see get current time, calculate, and all of that. So it basically extracts those, right? To extract those and then loads it up. And then depending on what the person is saying, is able to call that particular function and augment it. So it's passing it back to the model to use as response. And when it has decided that, okay, this is particular function that this person is calling, right? It then calls that function and appends the result. So you see now, we are getting what the response is. Then it now knows, okay, what function was actually said? What function did the model say I should call? Okay, the model said, maybe you ask what is the time. It depends, it assigns that, and then it now looks for it. Okay, based on the name, it now calls that function. See, execute function call. Basically, you're passing the function and then the parameters. There's some parameters. When you define a function, I say, okay, input parameters. The number, maybe input a plus b. Let's say we are trying to do quadratic equation mx ax squared plus bx plus c. Let's say your input is ax abc, right? Then you now get the root of the equation. Those are your inputs. It takes that, pass the results. You can see that it is appending that message and the result of the function back to the model, and then get your final response. So it's not like the function is inside the LLM. No, the first step is just like we have in the slides, right? The first step is it determines what function it is that you want to call, right? Step one, step one, right? Uh, User message plus two definition. Step two, the two calls, right? And step three is execute locally. So it like knows, okay, what function? See, app runs the function. If you see in the middle, you say, yeah, app runs the function. LLM does not execute code, right? So it knows, okay, this is the function I should call. It now goes back, calls the function, and after that, it's now adds that response from the function back to the LLM and gives an output. So that's the whole flow. And then we run this and test. Okay, we already did that. They said the current time is 11:55. Anyone can check their time and see that that is accurate to the second. That is not going to be possible if it was just an LLM. It's using the date time functionality, right? So that's basically it, guys. This is how you can power your solution with function calling and then structured outputs, right? Let's just use a final question of what is the square root of 44? Maybe let's see what response it gives us if it's able to generate that successfully. So it says square root of 14 is 144 is 12. So if you see that it is still answering in a natural language, it's not just as if it just used the calculator and told me 12, because the response from the function that is called is passed back to the LLM and it returns the whole response and the solution as a human-like chat response you get. So just like I mentioned, the final thing that we're going to run through is to see how a function calling solution to see how a function calling sorry, apologies for that, can be implemented, right? So let me sign out and sign in again. This is a Nigeria No Trade Hub that was built sometime in October at the MLSC Nigeria, right? And then yeah, it's an open source project that you can, okay, what's happening? But yeah, it's an open source project that is still open to contributions for. You can check it out, right? If you have any recommendations or questions. But let me just share the link in the chat so you can check it out in your spare time, actually, since we're running out of time, right? So if anyone has any question, please do kindly share with me now. I would like to take them before we wrap things up. So this is where we're going to end. I don't want to go beyond the 1 hour that we set for ourselves, right? But yeah, does anyone have any question? Any questions so far? And I believe we kind of understand the whole flow and implementation of how structured outputs works. Okay, also Nancy, I can see your hand. So I have some key takeaways here. Ditch prompt hacking, we already covered that. Design schemas first, connect to function calling, and start applying today, which is a summary of everything. Thank you. So yeah, Osinachi, your question, please.
Okay, good evening. Thank you very much for the presentation. Uh, yeah, so my question is in the use of like a multimodal element. So how can we like is it going to follow the same can we like tailor similar structured response to avoid the element accumulate?
Okay, yeah, I get you. Well, for multimodal cases, it's going to be a different case now because it's not exactly just JSON. But what you can do, because it has to do maybe images or something, you can set guardrails. But this focuses on just like text-based responses. I don't know if you get me, right? For things that have to do with image generation or inputting an image. I mean, if you're passing an image, it's still part of the inputs. If the response is purely text, structured output is still going to work fine. Or if you're calling a function to generate an image, that's still going to work fine as well. You get, so it's just more of how are you handling your input. What's your inputs? If your output is like maybe images, you're trying to generate images, then of course it takes a different tone, right? But if it's like multimodal inputs, this also still works. Everything is still part of your inputs, but then the schemas and everything are defined for the text-based outputs. I hope that answers your question. All right, thank you very much. I don't know if we have any more questions. Anyone has any question for me? So so I'm guessing in the absence of any question, we're going to end it here. Thank you very much, everyone, for taking our time to join in. I really appreciate it. I believe you must have gained one or two things, or even much more. And for those that are getting started in generative AI solutions, keep building and use structured outputs and functions. Thank you very much, everyone, for having me.